Reference data types are data types that are passed by their reference. Compare this with a value type. When you assign a value type or use it as function inputs or as outputs, the value will be copied. For reference type, the data will not be copied. Instead, a pointer to where the data actually is stored will be passed around. Reference data types that are available in Vyper are fixed size list, dynamic arrays, mappings, and structs. Now, I don't want to overload you with too much information in one video, so what I'm going to do is, in this video, I'll explain about fixed size list, mappings, and structs. In the next video, I'll explain about dynamic arrays. So let's begin with some examples. Let's start with a fixed size list. Let's create a list of uint256 having the size 10. Call this nums, and I'll make this a public state variable. Public. To declare that this will be a fixed size list of type uint256, we'll start with the type declaration, uint256. And then to declare that this is a list, we'll need to put a bracket, and to declare that it is a fixed size list, here we'll need to put in the size of this list. For this example, let's create a list of size 10. Okay, so how do we read and write into a fixed size list in Vyper? I'm going to show you how to read and write from a fixed size list inside the constructor. So I'll type deploy def underscore underscore init underscore underscore parentheses. Okay, and as a review, to reference a state variable, we'll need to say self and then followed by the name of the state variable, nums. Let's say that we wanted to get the value that is stored in index 0. Then what we will do is bracket 0. If you wanted to get the value stored in index 1, then we'll say 1. And to store a different value at index 0, we'll say equals and then assign some value. For example, let's say 1 to 3. As another example, let's store the value 456 at index 1. So say self.nums at index 1 store 456. Okay, so that's fixed size list. Next, let's take a look at a mapping. Mapping is a data type that is built off of two other value types. The first value type will represent the key of a mapping, and the other value type will represent the value of the mapping. Let's create a mapping called myMap. Again, this will be a public state variable. And to create a mapping, we'll call hash map and then brackets. And inside here, we'll need to declare the two value types. Let's say that we wanted to create a mapping that maps from an address type to uint256. So the first type will be an address, and the next type will be uint256. Okay, and to access a mapping, so let's also write some code inside the constructor. Say self.myMap. The key type for the mapping is an address. So let's say message.sender. And this is how you get the value for a mapping stored at this address. To store a different value for this myMap at this address, let's say equals to 1. Okay, as another example, let's say self.myMap. Again, let's say message.sender. So we want to update the value that is stored in myMap at this key message sender. Let's put 11. Okay, so this is an example of mapping. For the last example, let's take a look at structs. Let's begin by declaring a struct. To declare a struct, we will say struct, and let's call this person. The person struct will hold two data. The first data we'll call this name, and this will be a string having the length 10. And then let's also put in an age for this person. Let's say uint256. Okay, next let's create a state variable of type struct. Let's name this person. This will be public, and the data type that we're going to store is person, the struct person. Okay, let's now put some data into this person struct. So say self.person.name, let's call this Vyper, and self.person.age, let's say 33. Now, we can also load this state variable person into memory. The way we will do this is say, let's call this P, declare the type of this data. This will be a struct of person, and all we have to do to load it into memory from state variable is to say self.person. This will copy the state variable, so this will copy the data of name and age from state variable into memory into a variable called P. And if you wanted to now modify this data, we can say p.name, let's say is equal to solidity, and let's say p.age is equal to 22. Now, why am I showing you this? Well, the reason is the data Here, it's updating the state variable, so this data will be stored. Over here, it's making a copy into memory and then modifying the data that is stored in memory. So when we deploy this contract, this update will not be reflected. Okay, so let's now compile the contract. Click on the Vyper icon, click compile. Okay, our contract compiled. Let's now deploy this. Inside the deployment tab, the name of the file is called ref.py. I'll click deploy, scroll down, then open the contract, and let's call some getter functions. Let's start with nums. So for nums 0, let's try calling this, and we get the value 1, 2, 3. How about nums at 1? We get the value 4, 5, 6. How about nums at 2? Notice over here that we didn't set any value for nums at 2. So what will we get? Calling this, we get a 0. Can you guess what's going on here? We didn't set any values for nums at index 2, but when we called it, it returned a 0. The reason is all state variables come with a default value. So when we declared a fixed size array of size 10, we initialize the fixed size list where all of the elements are set to 0. And over here, we updated the value to 1, 2, 3, and 4, 5, 6. So the value stored at nums at 2 is still equal to 0. So this is why it's equal to 0 over here. Next, move on to the example of my map. This contract was deployed by message sender. And here is the address for message sender. I'm going to copy this account address and then paste it here and then call my map. And the value that is returned is 11, since this is the latest update that stores 11 for the key message sender. Okay, and finally, let's look at the example for person. Call this, and we get that it returns name equals to Vyper and age is equal to 33. This is because it updates the state variable here, and over here, it copies the state variable into memory. So the update that is made is not to a state variable, but to a data that is stored in memory. Once the contract is deployed, this memory is cleared, so we don't see this update.